Hello, in this video we'll be looking at the data collected in the experiment to estimate Planck's constant. So if you remember what we were doing, we were using LEDs, putting a voltage across them and then adjusting that voltage until the point where they were just lighting up, and then we were writing that down so that we could use that as a way of calculating or relating the photon energy to the relevant photon frequency. So we were collecting a bunch of threshold voltages which we need to calculate with, and they're going to go into this table here. So let me guide you through this spreadsheet that I'll be using. So let's zoom in on the results table here. Okay, so this is our results table, and as you can see in the first column I've color coded this so that it matches the LEDs that we were using. So we have a way of relating the LEDs we were using to all the other data. So we start off with an indigo, then a blue, yellow, green, orange, red, and then there's two that we couldn't see. They don't have colours that we can discern, but they were infrared 1 and infrared 2, I'm calling them. Okay, now the wavelengths were given to us, so we don't actually need to do any calculation there. I've just written them down in nanometers. So we have wavelength 1, 430 nanometers, 505, 560, and so on. So the wavelengths were given to us. I don't need to do anything to deduce those. The numbers that we need to put in are here. These are the first and second results for the threshold frequency per LED. So I'll put in the first result, the second result, and this will then calculate an average. It's just using a spreadsheet average formula that gives us the mean. Okay. I've also surrounded that with an if error to show a 0. It's just to keep it a bit tidy, otherwise it shows an error there when I have empty cells. So if error, give me the average. If there's a problem with that, then it will give me a 0. So this spreadsheet is a bit tidier than some of the other ones I've used. Okay, so what do we do with the numbers? The first thing I'll calculate is from the wavelength, I'll calculate the frequency of the photons that were being emitted by that LED. So if I go into this cell here, in the frequency column, how I'm doing that is, so it's probably a bit hard to see on the screen, but it's 3 times 10 to the power of 8, that's the first number here, okay? 3 times 10 to the power of 8 divided by the wavelength, but remember the wavelength is in nanometers, so I need to convert that into nanometers. So in brackets I'm doing this value here, this cell value, multiplied by 10 to the minus 9. And then I'm doing this additional thing here, again to keep the spreadsheet tidy, I'm divided by 10 to the power of 14. So all of my frequency values are going to come out in the 10 to the 14 Hertz range. So to keep things tidy, I'm dividing by 10 to the 14, and then at the top here you'll notice that I've put multiply by 10 to the 14. So these are the frequencies times 10 to the 14 Hertz. So this frequency here, you can see, is 6.98. The actual value is 6.98 times 10 to the 14 Hertz. Okay, so that's this final thing here. So often we will have data presented in that way to keep things tidy. So we put an additional factor before the unit so that we know it's actually bigger than what it's showing in the table or smaller than what's shown in the table. So that's the frequency column. Again, because the wavelengths were given to us and I've put the formula in here and I've filled it down, all those numbers are already there, they're already calculated. So we've got something from the range of 7 down to 3.1 times 10 to the 14 Hertz. So those are the frequencies. And then we have in the energy column, this is photon energy. Similar to before, I've done a scale here, so this is 10 to the minus 19 joules. So you see that final bit there is just to give us that factor so that the numbers are all tidy. All these will be about 10 to the minus 19 joules. So what we do here is we've got the voltage. Photon energy is related to the voltage through the charge on the electron multiplied by the potential difference that the electron moved through. So the charge on an electron, all electrons have the same charge, 1.6 times 10 to the minus 19 coulombs, that's this number here, so 1.6 times 10 to the minus 19. and then we multiply that by the average threshold voltage here. And then I'm doing that conversion at the end, just like I said, just to give us tidy numbers. So let's put some numbers in and see how it looks. So the first result for indigo was 1.52, the second one was 1.45, oops, wrong cell, 1.45. Okay, so the average is 1.49, and you can see that the energy has calculated, it's 2.38 times 10 to the minus 19 joules. So that's our value there. And these results, as I type them, will be plotted onto our graph grid down here automatically. So we'll look at that in a moment. Let's finish putting the data into the cells. So 1.23. Okay, these numbers should look familiar to you. These are the numbers collected in the experiment. Okay, so we have those numbers now. Let's have a look at how that appears on the graph. Okay, so I'm just going to zoom out one notch there. Okay, so here's our plot. As you can see, there's a very noticeable drop right in the middle here. We've got it seems like quite a nice trend with the first two and the last two plots. These three in the middle drop down. So that seems to be a quite obvious problem with the data that was collected there. Okay, so I've scaled the axes already, so we're going from 3 to 7 times 10 to the 14 hertz on the bottom here, and this is from 0.5 up to 2.5 times 10 to the minus 19 joules. So how do we analyse this graph? I've plotted the line of best fit already, so we've got a straight line, and what we want to do is we want to relate this straight line to the data, the equation that relates our data. The equation that relates our data is E equals HF, so that's photon energy equals Planck's constant multiplied by the frequency. So since we've plotted photon energy on the y-axis, the y variable is photon energy, and the x-axis is photon frequency, that's the f. So that means that anything multiplied by x in y equals mx plus c is the gradient. In our equation, E equals HF is just Planck's constant, so Planck's constant is equal to the gradient of our line. So that's what we're going to use to calculate. And you can see up here, I've got the equation of the line displayed here. The gradient is 0.3548. We just need to bear in mind that I've plotted 10 to the minus 19 joules versus 10 to the 14 hertz. So we need to do a little bit of a conversion there, but we don't actually need to do any further calculation with Planck's constant, with the gradient as such, to get Planck's constant. So that's our graph. Let's have a look at what the data actually has given us. You can see I've actually auto-calculated the gradient here and Planck's constant. So the gradient is calculated using the slope formula. So slope, and then I put in my E data. So all I did here is clicked on this column, and then I clicked on the F column for the second argument. So this range is the first argument, this range is the second argument there, okay, and that gives you a gradient for that data, and you'll see the number exactly matches what the gradient is shown on the graph. So I said 0.3548, and that's what we've got there. Okay, so the gradient is 0.3548, but as I said, we need to do a conversion there because of the factors or the scales on the axes there. So I need to take this value here, I need to multiply by 10 to the minus 19, that's that scale that dealt with, and then I also need to divide by 10 to the 14 hertz, that's that scale there. So I do those two conversions, and again, just to display this a bit more nicely, I know that when you do that, the value is going to come out in the 10 to the minus 34 range. So I've multiplied by 10 to the minus 34 and just added in something here to display 10 to the minus 34. So the value is 3.5478 times 10 to the minus 34 joule seconds. Now you'll know that Planck's constant is 6.62 times 10 to the minus 34 joule seconds. That's this value here. So we've got quite a large difference between what we've estimated and the data book value. It's actually 46% different. So in this cell here, I'm doing the difference between the gradient that I got and the gradient you'd get if you got 6.62, and then or 6.63 rather, and then I'm divided by that and I'm just displaying this as a percentage. So this is 46% difference. That's quite a lot of difference here. I've also added the intercept here using the Intercept Formula. For this data, it should go through the origin, but you can see that our data is not going through the origin, it's going through the y-axis at minus 0.22 times 10 to the minus 19 joules, so there is a bit of an offset there. Sometimes that can help you understand where you might have gone wrong. In this case, I'm not really going to analyse that, but I include that in my analysis and evaluation tables. So what could have gone wrong, I suppose you could say. One thing to note is that just as when you do an experiment, you want to do your experiment over a range of frequencies, like in this, you want a range of data, so that you can average over that range, and any anomalies like these three in the middle, or possibly even two at either ends, you can spot those much more easily. It is also worth repeating the whole experiment several times to see if you get better or more consistent results. You want consistent results. So when I've done this experiment before, I've done it several times, I've always tended to get something not too far away, about 20%. That's still quite far away, I grant you, but it's not 46% difference. So I need to think about what could have happened there. So just off the top of my head, some of the things: perhaps I didn't eliminate enough background light, perhaps I didn't allow my eyes to adjust to the darkness after every time I turn my torch on to take a reading from the multimeter. So those are some things that could have happened and affected the results, so that some of these data points were not very good. As we've seen, we've put our threshold voltages into the table, we've got a graph plotted, and we've got quite a disastrous result for our estimate of Planck's constant. But hey, sometimes data is messy and sometimes it doesn't go the way that you want, so that's something we'd have to just handle. And if you want to get this spreadsheet, you can get this spreadsheet. It's available through my website, so yeah, if you want to get this, by all means, check it out there. And I highly encourage you to have a go at the data analysis yourself. There is a worksheet that goes with this experiment, and you can compare your results to the results that I got in this spreadsheet. The worksheet is available through my website.